Welcome back. This is Mr. Wakefield, and we're going to be looking at section 5.4 now in the packet here in Math 71, and taking a look at these problems here that we have in this section. You see down here the first set of them. We got more on the back. They all have three terms. Now we talked about in the last section not only about how to do the GCF, which is the first thing that you always do in any factoring problem, like we said, but we also talked about how to factor four terms. We're also going to learn about how to factor three terms and two terms. This section is three terms. The next section is two terms, okay? So how do we factor three terms? Well, the first thing I need to say to you about that is that if we have three terms, okay, and assuming that you've already done the GCF step already and you're looking at your polynomial which is left over, and by the way, if the GCF is 1 in this case, you wouldn't factor that out, and so the leftover polynomial in that case, since you're skipping the GCF when it's equal to 1, is just the original polynomial. So either way, your leftover polynomial, if it looks like one of these four things here, where the green ones are the coefficients and the red ones are the variables, if it looks like those, and you can have some minuses in there too instead of the pluses, those are also okay. But if it looks like one of these four, you can factor it, okay? And by the way, this is assuming that the A is positive, all right? What I'm about to show you will not work unless the A is positive. So if the A is negative, whenever we run into that in the future, I'll show you about how to get out of that situation so that you can make it positive, okay? Make sure that the A is positive. Okay, again, right now it's going to be positive, so don't worry about it. If we run into some negative A's in the future, like I said, I'll show you a way to deal with that. Okay, we have two methods that I have listed here that I have taught my students for many, many years. But what I've discovered in just the last few years is a brand new method, which I'm going to show you instead. If you want to do one of these two methods here, contact me if you're unsure about it at all. Okay, but otherwise, we're going to do this new method that I learned. It is called the Berry method. Okay. Just to give you, you don't have to know how to write this down here, the Berry method, okay? What's important is you know how to do the method, not what the name of it is. Let me show you how it works, okay? Again, like always, you guys, anytime you factor a problem, and it says here to factor, okay, you always factor out the GCF first. But if the GCF is 1 in one of these trinomial problems, it's okay to skip that, okay? So we're going to skip that, and then we're going to move right into our method that we have for a three-term polynomial that is of one of the four forms that I showed you up here. And you can see here that this problem here is of one of those four forms, okay, because you have a y squared. In other words, you have a variable squared, and then you have a variable to the first power, and then no variable at all, in three terms there. Just like this one right here, okay, variable squared, variable, and then no variable at all. All right, it doesn't matter if it's a different letter like y, that's fine. So we can factor this thing. Same thing here. We got variable squared and then variable to the first power and then no variable at all. Okay. So let's take a look at that. What you do with the Berry method is you multiply the coefficient of the term that has the variable squared right there, the 5. You multiply that by negative 14. Okay, and that is going to be equal to negative 70. Okay. Negative 70. Here's what you do with negative 70. I'm going to make a little x right here, okay, or actually a big X. A lot of students like to do it this way. Okay, what we need, you guys, is we need to find two numbers that equal negative 70 when you multiply them together, but then they need to add up to 33, the middle coefficient. They need to add up to that middle coefficient, assuming that the terms are in this order. And make sure that they are, if they're not already, when you're trying to do this method. Okay, so what two numbers add up to 33 but are factors of negative 70? In other words, they need to multiply together to be negative 70. Well, as I showed you guys the other day, when you're doing your factors, okay, they are, make sure to do the 1 and the 70 and the 2 and the 35 and all that. But the problem with that is that this is not 70, it's negative 70, okay? So when it's negative, that top number in the big X right there, when that top number is negative, you need to do this. You need to consider negative 1 and 70, but you also need to consider 1 and negative 70 because those are two different possibilities. If you don't consider them both, you might end up missing the possibility that actually works. Okay, now these two pairs, do either one of those add up to 33? No, this one adds up to 69 and this one adds up to negative 69. How about if I make this one negative 2 and 35, but also 2 and negative 35? Again, you have to, for each pair of possible factors, you got to do negative positive and positive negative because they're two different possible answers there. Okay, do either one of these pairs add up to 33? Yeah, actually this one does, right? So we keep on, in other words, we keep on making our list of possible factors for negative 70 until we find one that works. If nothing works, after you've written out all the possible pairs of factors, all right, then we'll talk about what that means here coming up. We'll see a problem like that. But for the moment, since this works, what we're going to do is this, okay? And I shouldn't even write equal. What I'm about to write here is not equal yet, but it will eventually be on a future step here. Here's what you do. If this is 5y squared here, you guys, that means that you need to write down 5y and 5y. Okay. For example, in the next problem, you see how it says 4x squared? Since it's 4x squared, we're going to do 4x and 4x. I just want you to see how that whole thing works. So if it's 5y squared, you do 5y and 5y, assuming that you didn't factor out any GCF before that, which would then change that. But assuming you're on the step where you're doing the Berry method and the GCF step's already done, if it's 4x squared, you do 4x and 4x. If it's 5y squared, you do 5y and 5y. Okay, and we'll see plenty of examples of this. What you do with that, though, is you take those two numbers that I found down here that actually work. Let me put them up here as well, negative 2 and 35. You take those two numbers and you actually put them in here. And if one of them's positive, you got to put the plus there. You got to either have a minus or plus in front of each one, so don't forget that. The last thing you do, though, this is not the final answer. There's one more thing we got to do, okay? And that is we have to factor out the GCF out of each individual bracket, okay? Out of each individual bracket. What is the GCF of this bracket? Just looking at 5y minus 2, not the other bracket yet, just this one. Isn't the GCF equal to 1 right there? And since it is equal to 1, that means that if I factored it out, it's not going to change this. As we've talked about before, if you factor out 1, it's not going to change it. So you just write that down right there. And by the way, when you do the last step of the Berry method, unlike other problems where you factor out the GCF, when you do the last step of the Berry method, if you factor out a GCF, you actually take that GCF and you discard it. You get rid of it. You don't write the 1 in front of it, for example, all right? You just discard it. Let's do that same thing here on the second bracket. The GCF here is 5, isn't it? If I factor that out, this would become what? The y plus 7. But you got to get rid of the 5 that you just factored out. And again, in the last step of the Berry method, you get rid of the GCF. You don't always get rid of the GCF. When we did those problems yesterday where we factored out the GCF, you keep it in the front. You don't just get rid of it. But in the last step of the Berry method, that's the exception. That is when you actually get rid of it after you factor it out. And once you do the GCF on each bracket like that, then you are done. And we, as we said yesterday, normally when you get your two brackets, you're done with a factoring problem. We'll see the exception to that in the next section. But normally, when you get those two brackets there, you're done. Let's try that again here in problem B. Once again, the GCF is equal to 1, so you can skip that step here and go right into the Berry method, since this polynomial, or this trinomial, this three-term polynomial, which we call a trinomial, tri meaning 3, this trinomial fits the description of one of those 4 types of forms that I showed you at the top of the page when we first started this discussion. So what we do is we do 4 times 18. 4 times 18 is 72. And so what we need to do is we need to find two numbers that equal 72 when we multiply them, but they have to equal negative 27 in the middle there when we actually add them. So what we do again is we list out the factors of 72. Okay, what are the factors of 72? They are 1 and 72, 2 and 36. Now before I list out any more, let me just stop right there. Positive plus positive is never equal to a negative, is it? It's never going to be equal to a negative. But we also know that when you multiply two numbers together, okay, and they're equal to a positive, it could be negative and negative. Negative times negative is positive. So it is okay to do negative times negative here. But the reason why I'm doing that here, or I'm not always going to do that, the reason why I'm doing that here is that negative plus negative is always equal to a negative, and since we need it to add up to a negative, that's the only thing that could possibly work. It's not going to do us any good to try out positive 1 and positive 72, or positive 1 and positive positive 2 and positive 36 is not going to do any good to do that either, because we know that it's not going to add up to a negative. Okay, so let's review here. If this top number in the big X right here is negative, then you do this thing where you do two pairs for each pair of factors, negative positive and positive negative for each different pair of factors. But when that top number is positive, though, then the middle number, negative 27, that middle number is going to tell you what the sign of your factors are going to be. So if this had been positive 27, you would just make these all positive. Since it's negative, you're going to make these all negative. Okay, so let's keep going here. What is this going to equal? If I keep on listing out my pairs of factors, there's the next one. Doesn't that one add up to negative 27 though? It does, doesn't it? Okay, so again, you keep on going, you keep on listing out your factors until you find a pair that equal negative 27 when you add them together. Let me write that down, negative 3 and negative 24. So let's do that. Let's take those two numbers and put them in there with the 4x and the 4x, just like I did in the last problem with the 2 and the 35. Okay, so we got 4x minus 3 and 4x minus 24 here. Okay, so remember, there's one more step to the Berry method you got to do. You have to factor out the GCF out of each bracket here. The GCF on this one is 1, so that's not going to change it, right? You could still factor out the 1, theoretically, here. It's just that it's not going to change it, okay, when you do that. So I just bring that down. What's the GCF of this one? The GCF on this one, it's not 2, even though that is a common factor. It's actually 4, so make sure you get the greatest common factor. That's important. And if I factor out the 4, that is going to be equal to what? X minus 6. Again, throw out the GCF that you pull out of the brackets in the last step of the Berry method, okay? Make sure to do that. Don't just stick them in the front. And there you go. And that's the Berry method. We got our two brackets. We are done. Okay? All right, and problem C here. Notice that this problem is not in one of these forms up here. But remember what I said. You don't even consider whether or not the problem is in one of these forms until after you do the GCF, okay? What's important is that it's in one of these four forms after you have already factored out the GCF. And sure enough, this time there is a GCF, and you'll find out that after I factor it out, the leftover polynomial that we get will be in the one of those four forms. Okay, in fact, it will be in the first form just like the first two problems were. Okay, so the GCF here is actually 1y to the third, okay? 1y to the third. I figured that out just the same way I did in the last section. If I then factor that out, I then get 10y squared minus 17y plus 3. Okay, and so what does that mean now? It means now that after you factor out the GCF, you do the same thing with the leftover bracket as you did with the original problem over here where you skip the GCF step. Okay, again, you don't go back to the original problem when you do the Berry method. You have to do it based off of the leftover polynomial after you factor out the GCF. So what we do is we do 10 times 3. 10 times 3 is 30, right? So we take the 30, and we need to find two numbers that equal 30 when we multiply them, but they also have to add up to negative 17. Now, if you already know what the two numbers are, you don't need to make this list down here. That's okay with me, all right? But otherwise, carefully make this list here so you don't miss the right answer, okay? Just like we talked about before, systematically go through this, all right? Start out with the 1 and the 30, but remember, okay, it's a positive number, 30, and so it's either got to be positive, positive, or negative, negative in order to multiply together to be a positive answer. But because the bottom number is negative, just like in the last problem, if the top number is positive, we know that they've got to be the same sign, either negative, negative, or positive, positive, okay? But because the bottom one is negative, that means you're going to do the negative, negative possibility. Same thing here. The bottom number is negative, so we're going to do negative, 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 and you keep on going until you find the right one. Well, sure enough, this is the right one right here, isn't it? That adds up to negative 17. So we get this right here, okay? And then, just like always, and remember what I said. Unless you're in the last step of the Berry method, do not get rid of any GCFs that you factor out. So this y to the third, you have to bring that down, you guys. That is a part of the final answer here. All right. Do not forget to bring that down. Okay. It's just in the last step of the Berry method that you discard those GCFs from those brackets that you do. And we'll do that again here. We'll take a look at that, and you'll see the difference. But since this is 10y squared, you guys, just like in the last couple problems, if it's 10y squared, then we do 10y, 10y. 10y squared means 10y, 10y. Okay, now, we then put in minus 2 and minus 15 because those are the two numbers that we found. Okay, and then the last step of the Berry method is to what? It is to factor out the GCF out of each bracket, but then discard those GCFs, get rid of them. The GCF of the first bracket is 2. If I factor that out, I get 5y minus 1. If I factor out the GCF out of the second one, I get, and by the way, the GCF there is 5. So if I factor that out, I would get 2y minus 3. Okay? And so, notice that I got rid of the GCFs that I factored out of the two brackets, but I did not get rid of the original GCF that I factored out. That one's got to stick around, okay? And so this is the first time that we've seen a problem, you guys, where we had a GCF and then two brackets. The key thing to remember, again, bring that GCF down into the answer. You can't discard that original GCF, okay? All right. So now, let's go ahead and flip that worksheet over, and we'll keep going here. You notice that I gave you a bunch of space right here, okay? That was just something that I did in the past when I did both of the methods that are listed on the front, and I gave enough room to do both of them. We don't need to do that here. We're just going to do the Berry method, so plenty of space here, all right? But we don't need that much space. Let's just keep going here and keep doing what we've been doing. X squared plus 3x plus 8. The GCF is equal to 1, and so we can skip that step. We then have 1 times 8, because there's an invisible 1 in the front. 1 times 8 is equal to 8. And so we need the two numbers that we picked to add up to 3. So I take my 8, and since it's positive, that means that the two signs are going to be the same. But because this number is positive, the two signs I'm going to do are positive, positive, not negative, negative. Okay? So my possibilities then would be 1 and 8, 2 and 4, and that's it, right? There's no other possibilities for factors of 8 when they're positive, positive. The problem, though, is that neither one of those add up to 3, do they? Okay? And so we can't find, there's no possibility that works here. All right? Doesn't work, does it? Now, here's the thing. What happens when you have a polynomial and the GCF is equal to 1, which means you don't do that step. But then the method that you have to try to break the problem down into two brackets, that method doesn't work either. What happens when the GCF is 1 and then you can't break the thing down into two brackets after that? We have a name for that type of polynomial. It is called prime. Kind of like a prime number, okay? That's what a prime polynomial is. It's when, let me say it one more time, when the GCF is 1 in the original problem, and then you take what you got there and you try to break it down to two brackets. In this case, we'd use the Berry method to try to do it. But if that doesn't work to try to break it down into two brackets, then we call that prime when those two things are true. Okay? So let's keep on moving on here into the next problem. And you'll notice problems E and problem F, both of them look a little bit different, but they also fit one of those four descriptions that we have on the front side of the worksheet here. Notice that problem E fits this description where you got the variable to the sixth power and the variable to the third power, and then no variable at all. And then the problem F fits that description of when you have a variable squared, a totally different variable squared over here, and then in the middle you have those same two variables both to the first power. Okay, so as long as it fits one of these four descriptions after you do the GCF step, and we can skip the GCF step on those two problems because they're equal to 1. But as long as after the GCF step it fits any one of these four descriptions, we can do the Berry method on those. Okay, and so we're going to do the Berry method once again on problems E and F. All right, so let's go ahead and take a look at that. All right, starting out with problem E here. Since I'm skipping the GCF step, I'm going to go right to the Berry method and say 2 times 15 is 30. Okay, and since the middle number is 13, I'll write that down. Okay, don't be tricked here. The answer is not 2 and 15, okay, because you would need one of those to be negative in order to add up to 13. However, when the top number is positive, you can't have one negative and one positive. It's either got to be both negative or both positive when that happens, when the top number is positive. And which one is it going to be? Well, since the bottom number is positive, then that means that these are going to be positive, positive. Okay, 1 and 30, for example, 2 and 15, those do not add up to 13, at least not yet. But then how about 3 and 10? Oh, there we go. That one adds up to 13, doesn't it? Okay, equals 30 when you multiply those two numbers, adds up to 13 when you add them together. Okay, now listen carefully here. This one's a little bit different because of the exponents being different, okay? Instead of doing 2y like we did before, it's going to be very similar to that though. We still do the 2 and the 2, okay? We still do the 2 and the 2 because the coefficient's 2. That doesn't change. But what is different though is that you take the y to the 6 and you cut that exponent in half, okay? It's y to the third and y to the third. So if you have 2y to the 6, you're going to do 2y3 and 2y3. Okay, it's no different than what we did before where if you had, again, let me flip over to the front. See how we went from 4x squared to 4x, okay? You're cutting the exponent in half, all right? The 2 gets cut in half, and now it's x to the first and x to the first. It's no different here, okay? You're cutting the exponent in half, all right? So the 6 becomes 3 and 3. All right, but you have to do it that way, okay? You can't get all creative and say 2y squared and 2y to the fourth, okay? It has to be the same exponent, so you cut the 6 in half on both of those, and that'll work. Okay, but you're still going to have the 2 and the 2, just like you would have before. All right. So what do we get here? We put in the plus 3 and the plus 10. Again, if they're positive numbers, you got to put the pluses in front of them, plus 3 and plus 10. And then finally, we get to the last step right here. We factor out the GCF out of each bracket. The first bracket is going to be 1, so that's not going to change. that bracket right there. And then the second one, though, has a GCF of 2. And so if I factored the 2 out of this bracket, I get y to the third plus 5. And we've got our two brackets. And we completed the Berry method, so we're done. One more to go here, you guys. All right. Again, this fits the description of one of the problems on the one of the 4 formats that I had on the front with the red and the green, just like I just talked about. And so since the GCF is equal to 1, we are going to skip that step and go right to the Berry method. 6 times negative 6 is equal to negative 36. Okay, remember that negative is a part of that final coefficient, so don't forget that. Negative 36, though, is what the top number is. The bottom number is going to be negative 5. Again, if you already know the two numbers that work here, go ahead and jump right to the next step. Otherwise, let's take a look at negative 36. Remember what I said earlier about when this number is negative, okay, you need to take each pair of factors. The first one would be 1 and 36. And you either do negative positive or positive negative. Okay, you got to consider both of those. Negative positive, positive negative. All right. Neither one of those pairs adds up to negative 5 though, so we keep going. Negative 2 and 18, 2 and negative 18. All right. Neither one of those add up to negative 5. So then we do negative 3 and 12, 3 and negative 12. Still doesn't add up to negative 5, neither one of those, but we're almost there. Negative 4 and 9. Oh, hey, that adds up to, oh, no, wait a minute. That adds up to positive 5, right? Okay, so be careful there. It's real easy to make that mistake there with your signs. That is not the right one, but this one is 4 and negative 9. So it took a while, but we got there. So what do we got here? We're going to do... Again, if it's 6x squared, we're going to do 6x and 6x. Again, you cut the exponent in half. All right, so 2 becomes x to the first. And then we put our numbers in there. But here's what's different, though, you guys. Just in the problem where it has the second variable here at the end, the y at the end, or in other words, if you have a variable at the end that's different than the one at the beginning, one of those types, in that case, you guys, you do not just put plus 4 and minus 9. Okay, what you need to do along with putting plus 4 and minus 9 is you also got to put a y in there. And you do the same thing you did with y squared as you did with x squared. You cut the exponent in half. 2 becomes 1 on both of those, so it's y to the first on both of these. Okay, again, you just do that in that one where you have the two different variables, one at the beginning and one at the end. Okay, just on those. Now let's go ahead and get to the last step of the Berry method, which means to factor out the GCF out of each bracket here. And we get, if we do that, we get 3x plus 2y because the GCF is equal to 2 on that one. Okay, so we factor that out and get rid of that GCF. And then the second one here, the GCF is 3. And so if I factor that out, I get 2x minus 3y, okay? And then you've got your two brackets and the Berry method is complete. Okay, so that's the basics there of how to factor a trinomial. Okay, you'll notice down here in the bottom set of problems down here, these 6 problems here, one of them has x4, x2. Again, that fits one of the 4 types of formats that we had on the front there at the top of the page that I wrote down. Just remember that when you do that step where you bring down you know, like where we normally do like 2y, 2y, or 4x, 4x, when we bring that down into the two brackets, this is going to be, again, the exponent is going to get cut in half. So you're going to bring down, because this is 1x to the fourth, you're going to do 1x squared, 1x squared. Okay, 1 means you bring down 1 and 1, but then, in fact, I'll go ahead and start it off for you here. So you're going to bring down 1 and 1 because that's 1, but then you're going to cut the exponent in half, and so at least initially, this is what the problem is going to look like. Okay, I'll let you finish that off though. So go ahead and please try problems 1 through 6. Hit the pause on your video and go ahead and hit play when you're ready to take a look at the answers. All right, guys, let's take a look at those answers here. In number 1 here again, the GCF is equal to 1, so we skip that step. We then do 3 times 8 is equal to 24, as you can see listed over here. So then I list out the factors of 24 until I find a pair that add up to negative 14, as you can see down here. And sure enough, negative 12 and negative 2 will do the job, okay? They're the ones that add up. So what we do is we put that in there, okay? And we get 3x minus 12, 3x minus 2. But we're not done yet, are we? Okay, we then need to factor out the GCF out of each bracket. And if I factor it out of this first one here, I get x minus 4. In other words, I factor out 3, and then I get rid of the 3 there. And then in the second bracket, though, the GCF is 1, and so that's not going to change that bracket, is it? And there you go. The last step of the Berry method is done. So that's number 1. In number 2, though, as you can see there is a GCF there. So don't be alarmed by the fact that it doesn't look like one of the types of trinomials that we normally use the Berry method on. If we factor out the GCF, then the leftover polynomial right there is in one of the forms that we have that we can do the Berry method on. We got z to the second power and then z to the first power and then no variable at all. So that fits the normal description of the Berry method. Again, don't forget to bring down the 4z to the third on the next step as you try to make 2 brackets here. But the way you make the 2 brackets is you multiply the 8 times the negative 3. We get negative 24, but it needs to add up to that middle number, negative 5. And sure enough, the 2 numbers that work, okay, are 8 and negative 3. Okay, and I made a list over here, and it ends up becoming this whole big list right here. I then put in the plus 3 and the minus 8. It does not matter which one you put first because it's going to end up being the same 2 brackets being multiplied together anyway, so the order doesn't matter. So you can put the minus 8 first and then the plus 3 over here if you want. That's fine. But again, bringing down the original GCF all the way down here on each step, the 2 brackets then become 8z plus 3 and 8z minus 8. But then I have to factor out the GCF out of each bracket. The first one is I got a GCF of 1, so that doesn't change. The second one has a GCF of 8, so it becomes z minus 1 when I factor out the 8. Okay. In number 3, I apologize here. This isn't normally going to happen, so I feel like I should apologize. Okay, again, the GCF is 1, all right, and so we eventually are going to have 16y and 16y coming down here. But the problem is that 16 times negative 27, that is equal to negative 400. Let me move this over so you can see it. Negative 432. Okay, again, I promise you this isn't normally going to happen. Okay, but this leads to this gigantic list of numbers, okay, factors of 432. And eventually, if you get all the way down to the bottom here, we end up with negative, let me bring it up here, negative 18 and, pardon me, 18 and negative 24. 18 and negative 24. Those are the 2 numbers then that would go in here, 18 and negative 24. Again, I promise you it won't normally be anywhere near that bad as far as the number of factors or how big this number is, negative 432. Okay, but that's how it comes out. If I then factor out the GCF out of each bracket, like I normally do on the last step, I get these 2 brackets right here. So that's number 3, okay? Painful as it looks, okay? You can eventually get to the answer there. Okay, so that is number 3. Number 4, okay, how did I get that answer right there? Again, the GCF is equal to 1, okay? And so, I have 1, the invisible 1 there, times negative 18 is negative 18. Okay, the 2 numbers that are going to add up to the middle number, negative 3, however, are 3 and negative 6. 3 and negative 6. And so, But remember, you guys, when you got one of those problems where you got the two different variables, okay, you got to put that variable here down here at the end. You got to put that in there with the 3 and the -6, cutting the exponent in half like usual. So y squared becomes y to the first and y to the first. And both of these brackets have a GCF of 1, so that's why you don't see an additional step right there. Okay, if I do the last step of the Berry method, it's not gonna change anything. So that's why I boxed in that answer now. Okay, but try to, as always, try to do that last step of the Berry method. It's just that it didn't change anything there. Number 5. Okay, in number 5 we have the GCF is 1. We multiply the 1 times the -5. It gives me -5. -5 then, in order to get a number of -4 in the middle, the only numbers that will work are -5 and +1. So I put those in there. Why did I put x squared and x squared in there? As I mentioned a few minutes ago, just before you guys started these problems, okay, 1x to the 4th means 1 and 1, okay, for the coefficients, but then you cut the exponents in half, x squared and x squared. 4 becomes 2 and 2. Okay, and after putting them the -5 and the +1, you then have two brackets that both have a GCF of 1, and so therefore the last step of the Berry method is already completed. Okay, and so that brings us finally here to problem number 6. Okay, let's take a look at that here again. The GCF is 1, okay, like it is so often. So we do 2 times 10 is 20. Okay, 20 is a positive number, so we need what? We need move this up here and zoom in a little bit better there. We need the numbers to be positive and positive because they need to add up to +9. And sure enough, the two numbers that work then would be 4 and 5. 5 and 4, doesn't matter what order you put it in, like I said. So the next step then is going to be 2x to the 3rd plus 5, 2x to the 3rd plus 4. Okay, the 2 and the 2 come down. The exponent gets cut in half, x to the 3rd, x to the 3rd, and then you do +5 plus 4. Okay, and then we factor out the GCF out of the second bracket here because the first bracket has a GCF of 1, so you don't need to change that. But if you factor out the GCF out of the second bracket, you end up with x to the 3rd plus 2, and that completes that. So this is how you factor 3 terms, you guys. This is how you factor trinomials. And so the last thing we need to talk about in terms of factoring is how to factor 2 terms. Okay, and we will talk about that in the next section. In the meantime, though, contact me if you have any questions about this. Take care.